Welcome to Summarize Science, where we break down the latest breakthroughs in technology and design. Today, we are looking at how robots are helping solve the massive waste problem in the construction industry. Traditionally, building follows a linear path where materials are extracted, used once, and then simply thrown away. Researchers are now proposing a circular approach that focuses on reusing old materials like timber to build new, complex structures. The main challenge is that reclaimed wood comes in all sorts of different shapes and sizes, making it hard for standard machines to use. To solve this, the researchers developed a system that uses computational design to plan buildings based on whatever wood is available. This project is called Timbrelyn, a stunning installation built at the historic site of the 1969 Woodstock Festival. The process starts by taking apart old structures and roughly sorting the wood into bins based on length. Instead of humans doing all the math, a computer program generates a 3D model that adapts to these varying lengths. The design uses a layer-based system where pieces of wood are stacked and overlapped to create strength. One of the most exciting parts is the co-robotic assembly, where humans and robots work as a team. A robot is equipped with a high-tech camera and a vision system to identify individual pieces of wood among a pile of scraps. Once a piece is selected, the robot uses a laser scanner to create a perfect digital 3D version of that specific timber element. This allows the robot to understand the exact dimensions and any imperfections the wood might have before any work begins. The robot then precisely cuts the wood to the right length and miter angles using a computer-controlled saw. After cutting, the robot moves the piece into its exact place in the structure and holds it steady. A human collaborator then steps in to nail the piece down, ensuring everything is secure. This bidirectional system means the computer model is constantly updated based on exactly how the last piece was placed. It creates a feedback loop where the digital plan and the physical building are always in perfect sync. For the Timbrelyn project, a total of 1,838 timber elements were used to create a beautiful, wave-like structure. Remarkably, over 91% of these pieces were robotically cut and placed with incredible precision. Even very short pieces of wood that would normally be useless were integrated to fill in structural gaps. The final result is a hybrid of weathered, reclaimed wood and new timber that creates a unique and tactile texture. This method proves that using imperfect recycled materials doesn't have to result in imperfect buildings. By letting robots handle the tedious task of measuring and matching irregular parts, reuse becomes much more practical for the industry. To recap, the researchers combined computer algorithms, robot vision, and human skill to turn old wood into a high-tech masterpiece. This framework minimizes waste and significantly reduces the carbon footprint of new construction projects. It also allows architects to create expressive shapes that were previously too difficult to build using scraps. In the future, this technology could be expanded to identify defects like knots or cracks automatically using multimodal sensors. It could eventually be applied to many other materials, helping us build a more sustainable world one recycled piece at a time. Thanks for watching Summarize Science, and stay tuned for more amazing stories from the world of innovation.